Thanks, Sunil. Okay, well, if you have set up some sort of gauging solution using multiple electronic gauges or LVDTs and so forth, you know that once you get more than a handful of gauges on a test jig, both the cabling and the instrumentation can actually become somewhat of a barrier. I mean, typically, if you look at a let's say a more complex gauging setup, you might have a separate digital readout for each gauge. So if you have a complex setup, you might have a number of different types of gauges, digital gauges, analog gauges. All these have got to be cabled into typically another piece of equipment with an individual readout on each one. So you've got all these cables running around. So both from a cabling standpoint and actually from a usability standpoint, it becomes somewhat of an issue once you get a lot of gauges. So the use of multiplexing addresses this issue. With a multiplexer, the output of a bunch of individual gauges can be combined into a single output and sent to a computer where it then undergoes demultiplexing and display. So there's a lot of advantages to this approach. Hopefully, if we have him on the Skype right now, here to discuss this a bit more in depth is Stuart Graham of Hyde & Hein. Hello, Stuart. How are you this morning? Oh, get the audio up on Stuart there. Hey, Stuart.
Hey.
Hey, sorry about that. So if you can just briefly describe, I mean, really quickly, so we can get on some other questions here, briefly describe what multiplexing is.
So basically, multiplexing is taking a bunch of different signals. In this case, it would be a number of gauges, and combining them digitally and logically, and then sending them through one means of transport to output. So in our case, it would be over Ethernet to a PC.
Okay, and what kind of signals, let's say, I know Hyde & Hein obviously makes a multiplexer. What kind of signals can a multiplexer accept? I mean, is it analog signals, digital signals? What kind of equipment?
The MSC 1000 can take 1 volt peak to peak, an NDAT currently, and we are rolling out analog, TTL, and LVDT modules as well.
Okay, and are there any, I've worked with multiplexers before, and I know one of the limitations, or can be a limitation, is if you're looking at a lot of gauges, is the ability to take a snapshot of all of the gauges at the same time. And so this gets down, for those of you familiar with multiplexing, you may have to pull individual gauges, gauge number 1, number 2, number 3, number 4. By the time it gauge to 15, there's a bit of a delay between reading the first gauge, reading the last gauge, as opposed to reading them all simultaneously. So is that an issue? And if it is, what are the limitations, if any, of a multiplexer system?
Okay, so our system specifically for our Ethernet connection, we utilize UDP, User Datagram Protocol. And what that allows you to do is, we do pull sequentially, so we'll look at each one. But you can also choose to pick specific gauges individually, so you don't have to look at each probe before you look back at the first one again. And there would be a time delay there, but utilizing UDP rather than TCP/IP allows for a quicker transmission, so that's how we get around that. Okay. And we can take up to 250 inputs, and it'll update faster than the computer screen can refresh. So. Okay.
Actually, Daniel, I think we've got some B-roll there of Hyde & Hein's particular product. If you could run that, and then maybe Stuart, if you can talk over the top of what we're looking at here.
And this was shot in Chicago last month, I believe.
Chicago last month, yeah. So this is at your booth, and I believe that's one of your multiplexers we're going to zoom in on. Okay, what are we seeing here?
So here's the power module. This is the MSC 1000. Next to it is the basic communication module, and you'll see an Ethernet port there, and that's where it communicates with the PC. There's also 4 and 8 total. Those are NDAT probes. That's Hyde & Hein's bidirectional communication. And you can see there it's mounted on a standard DIN rail mount for easy mounting. And there's some Acanto Hyde & Hein probes and a machine that's going to measure a camshaft, so it's pulling it off right there. It's going to load on a new one. Some pneumatics are going to drop down some gauges.
So this is another application we're talking about where you might be able to use digital outputs from a multiplexer to control another piece of machinery. In that case, the arm that is actually loading the test fixture.
Yeah, on here we don't actually have the I/O module or input-output module, but there is an I/O module that will output 5-volt TTL signals. So you can program basic go, no-go type tolerancing things, and then you can send over a signal to a PLC to tell it to load a new part or what have you.
And just quickly, so I see all those black cables coming out of the back on the right-hand side there, so that's the right-hand side. Those are the multiplexer input cables, right?
Yes,
and
those are the
encoder. And you can just stack up those modules to give you up, what'd you say, up to 200 inputs?
We spec it for 250, up to 250. We tested it with 300, and like I said earlier, it was updating faster than we could see it, so
okay,
it's pretty quick.
All right. Now we are gonna. There is going to be a webinar on multiplexer technology coming up.
That's next Tuesday. That's the 8th of October, and it's 2 p.m. Eastern and 11 a.m. Pacific. So check that out. Actually, there's an article right below the player page right here. Again, you can register for the webinar right through there.
And there's kind of a brief overview of what we just talked about, as well as a link. Yeah, a link out to the webinar.
And you and Stuart are going to be presenting together on that one. So Stuart's presenting.
Right. I'll be
moderating.
I'll be the dummy, and Stuart will explain it all to me and to the attendees of the webinar. So, Stuart, thank you for joining us today.
Thank you.
All right.
We'll see you on Tuesday, Stuart. Thanks a lot.
All right. Another tech story here.